Good afternoon, students. I'm Syed here from Civilsoft Structural Consultant and Trainers. So today we would be discussing the role of a structural engineer in design and construction of a building. So to start with, whenever you decide to construct a building, what you do is you go to an architect. An architect is someone who transforms the client's requirement into a 2D plan. This plan includes the dimensions of the rooms, kitchens, the living area, the entrance, the windows, and all that. It will have nothing to do with the location of beams and location of columns and the thickness of slabs. Once the architect prepares this architectural working drawing, he sends this drawing to a structural engineer. Structural engineer is someone who locates the position of columns and beams and the thickness of slabs. So he'll prepare a drawing which will include the sizes of beams, the location of columns, and the thickness of the slab. This drawing will be known as a GA. So architect is someone who prepares a floor plan. Floor plan is basically a drawing which includes or shows the location of rooms, kitchens, hall, toilet, and all that. Structural engineer, what he does, he prepares a drawing which locates or shows the position of beams, columns, and the thickness of slab. So once the structural engineer has prepared this drawing, which is known as the GA, general arrangement, also known as beam and column layout, also known as shuttering layout, he'll send this drawing to the architect for approval. See, we cannot put wherever columns we want because architect might have thought about something there in that particular position. So we have to get the approval from the architect before we start preparing the model. So once we get the approval and once the architect says that the drawing is okay, we can go ahead with the plan of our beam and column locations, we'll prepare the model. The model is basically done in ETABS or it is done in STAT. See, 90 to 95% of all the projects are done in these two softwares. So if you are a structural engineer, you need to know the softwares. It's like knowing bending moment diagram and shear force diagram. You need to know these things. Without this, you cannot be a structural engineer. So we'll prepare the model either in STAT or ETABS. The geometry part we'll do as per the GA. Then we'll get into the loading. The loading will include dead load, live load, earthquake load, wind load, temperature load. These are the 5 basic type of loads we usually apply. Coming to dead load will be classified into self-fade, floor finish, and wall load. For dead load purpose, we refer to code IS 875 part 1, and for live load we will be referring to code IS 875 part 2. Live load will be classified into typical live load and roof live load. See, live load depends upon the type of occupancy. You cannot have same live load in a residential complex and the same live load in a educational complex. It varies. This variation is given by the code IS 875 part 2. So based on that, we'll apply live load. Then coming to wind load. Wind load, again it differs. For example, here in Bangalore, the wind speed is around 34 meters per second. But if you go towards Chennai, it might be more than 34. I don't know how much exact, maybe 40, 45 or 48 meters per second. So depending upon where exactly the building is constructed, we'll calculate the wind load for that particular area. This is given in the code book IS 875 part 3. So based on that, we'll calculate what is the wind load and we'll apply to the we'll apply to the structure. Next comes earthquake load. As you are aware, India is classified into 4 zones, zone 2, zone 3, zone 4 and zone 5. For earthquake load, we refer to a code which is known as IS 1893-2016. Based on that, we'll apply earthquake load. Earthquake load is predominant in horizontal direction, but we have a vertical component also. This vertical component is not generally used. After earthquake, we'll have temperature load. After that we have applied all the loads, we need to combine all the loads. For the combination purpose, what we do is we refer to a code IS 875 part 5. We have to combine all this and then we'll run the analysis. We run the analysis basically to find out what is the axial load generated in the columns or what is the bending and shear force generated in the beams. Once we know these values, we run the design. After we have run the design, we have to prepare the various drawings that are needed to start the construction. First and foremost, the drawing needed would be your excavation layout. Using the excavation layout, the site engineer will excavate the earth. After we have released excavation layout, the excavation would be completed on the site. After excavation is completed, the next drawing to be released is your column and footing layout. Column and footing layout will indicate where which column is going to come and where which footing is going to come. It has nothing to do with the dimension of the beams and the dimension of the column. Next drawing, which is known as your column schedule, will include all this. It will include what is the size of the column, what is the size of the footing, and what steel will go in that particular column or particular footing. So column layout and column schedule indicates where the column or the footing is going to come. Your column and footing schedule indicates how much steel is going to come in that. Next is your plinth beam details. Once you have constructed footings, once you have constructed columns, the next drawing to be released is your plinth beam layout. So this plinth beam layout will mention where which beam has to come. After that, we'll be giving one more drawing which is known as typical plinth beam details. Basically, the plinth beam, the steel in the plinth beam is more over the same in all the beams. That's why we give a typical detail. A typical detail indicates that the same steel has to put in all the plinth beams, so you don't have to worry much about plinth beam. After plinth beam, next is the same column will be raised using the column schedule. And then when you come to first floor, the first floor you have to do shuttering work there, so the carpenter will be called in. So you have to give some drawing for the carpenter to refer to. That drawing is known as a shuttering layout. The same drawing what we had given earlier for the architect for approval, the same drawing would be given to the carpenter, the shuttering guy. He'll prepare the shuttering work using the same drawing. That's why it is also known as shuttering layout. After the shuttering layout after the shuttering work is done, the next thing is the slab. For the slab, we'll be releasing a drawing which is known as slab details. So the barbender will come and he'll put all the steel what is needed in the slabs. The next part would be the beam details. For the beam details, we'll prepare one more drawing which will be known as beam details. Using this, the barbender will put the steel in the beams. After we have done that, your excavation is done, your column footing is done, your columns are done, your plinth beam is done, your slabs are done, and your beams are done. The same procedure will be repeated. But there are few details that we have to give to the site engineer. Those details will not be mentioned in these drawings. So there will be some new drawings, some separate drawings. These drawings will be your typical details. A drawing will be given known as typical details. This will include typical details of each and every column. One column will be shown with every details that are needed. One beam will be shown with all details. One slab will be shown in all details. So this will be known as typical details. And there will be some general things that we have to tell to the site engineer. Here, this grade of concrete you have to use. This will be the lapping length. Do this, do that. When to remove the shuttering and all that. This information is given in the drawing known as general notes. So general notes will be given. And then a report of the project will be made, that what type of load you have applied, which code book you have referred, what is the grade of concrete you have used. The entire project report will be made. This report is known as a DBR, Design Basis Report. Understood? So this will be the role of a structural engineer. So as a structural engineer, you need to know all this. You cannot just learn ETABS and STAD and say that you know the design part. There's a lot to it. ETABS and STAD is only a fraction of the work, let's say around 20 to 25%. The remaining 75% is all this detailing part. How to prepare this column and footing layout, column and footing schedule, then your plinth beam layout, typical plinth beam details, then the shuttering layout, then slab details, beam details, your typical details, your general notes, your DBR, then how to apply the different type of loads, the different codes that has to be used, the detailing techniques. For example, you have two techniques such as ordinary detailing and ductile detailing. Ordinary detailing we refer to SP, 34. For ductile detailing, we refer to IS 13920 2002 or 2016. So all these things has to be learned. You cannot learn only ETABS modeling part and say that you know. The detailing is done manually. None of us use the software for detailing purpose. You might have seen few people, some videos where they run detailing. The beam details are directly extracted from the software. Nobody uses that in the industry. So this part and all will be covered here in Civilsoft Structural Consultant Trainers. So you need more details and you want to become a structural engineer and to see in detail how things are done in the industry, you can come and get enrolled here, work with us, and learn how things are done in the industry. So if you need more details, you can log on to our website www.civilsoft.in, or you can call us. My contact number is 901 99 77799. Let me repeat, 901 99 77799. Thank you.